I'm going to start today's video for topic 5, paper 1 questions, looking at these two graphs here. Remember that this graph here represents exothermic reactions and this graph represents endothermic reactions. And the difference is that reactants will have a higher potential energy and the products will have a lower potential energy in an exothermic reaction. And that in an exothermic reaction, energy is released in the form of heat that's represented here by this red line. And the difference for endothermic is that the reactants are going to be lower in energy and the products are going to be higher in energy when it's an endothermic process, and you're going to have energy, this much energy being absorbed. So one question that I got on the Google Classroom was, how do you know if the products or the reactants are more energetically stable in an exothermic reaction? So you would see that the exothermic reaction has products that are more energetically stable. In other words, less energy. So in an exothermic process, the products have lower energy. They are more energetically stable. Whereas in an endothermic reaction, the reactants are lower and the products are higher. So the products are not more energetically stable there. Okay. So I'm going to go through some of the questions that were asked. I'm going to start with number 6. So number 6 asks you to calculate using the average bond enthalpies. And then it gives you two values. It gives you the value for the single bond O to O and then the double bond O to O. The only thing they don't give you is the H to O bond or the OH bond. Okay, so you can find that in the data booklet, which I posted on December 10th, or even on the previous assignment, the assignment that you did for average bond enthalpies, it's given there and it's the same value. So I'll show you right here. I made some notes for number 6. Okay, you're doing average bond enthalpies. The way you do is you take the sum of the reactants minus the sum of the products. All the values are given to you except for this one, which is 463 kilojoules per mole. But you could find that in the data booklet, which I posted on December 10th, or in the average bond enthalpies assignment. Okay, next, you asked me about number 7. And it says, when these two solids are mixed, a solution is produced and the temperature drops. Which statement about the energetics of this reaction is correct? So when it says that the temperature drops, that means that it gets colder. Okay, so these are my notes on number 7. If the temperature decreases, that means it gets colder. That's an indication of an endothermic reaction. If heat was released, then you would feel it get hotter, which means the temperature would go up. So the opposite, if the temperature goes down, then it gets colder, which means it's an endothermic reaction. And so to answer that question, you have to remember that for an endothermic reaction, a delta H value is going to be positive. So that's how you have to remember that endothermic delta H is positive. That's how you answer number 7. I had a question on number 9. Number 9 has a graph like the ones I just talked about. Which of the quantities in an enthalpy level diagram below are affected by the use of a catalyst? So if we add a catalyst, so what I've drawn here is a diagram. Everything in black is basically what's given to you on the problem. And then you should know in blue here, if you add a catalyst, it gives it a different route that has a lower activation energy. So this is going to change and this is going to change. So based on that information, you should be able to answer number 9. Next, I'm going to go over number 12. Okay, so for this one, it gives 2 strong acids. And we haven't done the acid topic, which is topic 8 yet. But just so you guys know, both HCl and H2SO4 are both strong acids. It says that they have the same concentration and they use the same volume to neutralize NaOH. And then it gives you this information. So this is going to be the HCl is going to be corresponding to X, and the H2SO4 is going to be corresponding to Y. And then it asks you which statement is correct. So let me show you how I came up with the correct answer. So here's number 12. So I'm looking at HCl and H2SO4. I'm noticing that this one has 1 hydrogen and this one has 2, which means that you're going to need twice as much HCl for the same amount of H2SO4, and that's how I came up with the answer that 2X equals 1Y. You need 2 of the HCl's because there's only 1 hydrogen to 1 of the H2SO4s. So that's how I came up with my answer for number 12. Okay, it's based on the hydrogens, which we will discuss more in detail in topic 8. Next, I'm going to go to number 14. Number 14 says the mass of a substance is of specific capacity C increases by T degrees Celsius. What is the heat change in joules? Okay, so this is just Q equals MC delta T. Notice they don't have the delta here, but you guys should know that that's the change in temperature, the change in temperature, the change in temperature. That's what they're referring to, okay? So here's the thing. You look at the units. You see that grams are going to cancel, and you see that you want your temperature units to cancel. So Kelvin and degrees C are not going to cancel, but it doesn't matter actually. So the answer ends up being just A, and let me show you why. So here's our formula, right? Q equals MC delta T. So to find Q, which is what the question's asking for, you just take the mass and multiply it by the specific heat and multiply it by the change in temperature. So actually, it doesn't matter if it's in degrees C or Kelvin because it's going to be the same amount of change. If it goes up by 3 degrees Kelvin, it's the same as going up by 3 degrees Celsius. So the answer there is just MC times T, which was option A. Next, I'm going to go over 16. 16 says, the following equation shows the formation of magnesium oxide from magnesium metal. So we have a delta H value that's given to be negative 1204 for the whole reaction. First of all, negative delta H, right away, you should think it's definitely exothermic, which means heat is definitely released. So it's definitely not B. So you can eliminate B right away. Then it asks you compare it to the magnesium. So if you look at the magnesium, notice that there's a coefficient of 2. This is how much energy is going to be released for 2 moles of magnesium. The only option there then is letter D. There's 1204 kilojoules of energy released for every 2 moles of magnesium oxide. It's the only one that is correct. If you were to look at letter A, that's wrong because it says only 1 mole of magnesium and there's 2 moles of magnesium. So 16, the only correct answer is letter D. Next, I'm going to go to 19. 19 says, okay, so for this reaction, and it's average bond enthalpy. So you should be able to do that. It's, again, 19 right here. It's reactants minus products, just like we were doing in number 6, okay? But this one doesn't give you numbers, so you just have to kind of figure it out. So based on the information that they give you, it's 2x plus y minus 2 times 2z, which ends up simplifying to 2x plus y minus 4z. And again, y, look at this. 2 times x plus 1, because the coefficient is 1, times z, minus, I'm sorry, not z, y, I'm sorry, but y, because this is a double bonded O. You guys should know that O2 is a double bonded O. And then minus the product, so here's the products, and there's 2 of them, so you have to multiply 2 times the 2 OH bonds in water, and so that's why it ends up being 2 times z, which is 4z. So the only correct option there is right here, 2x plus y, those are the reactants, minus the products, which is 4z. So letter C. Okay, then I'm going to go on to 28. Number 28 asks about the specific heat capacity of these metals, and it says, which metal will show the greatest temperature increase if 50 joules of heat is supplied to 0.001 kilogram sample of each metal? Okay, so you are looking for specific heat capacity means that it can hold a lot of heat. If you want to know which one is going to have the greatest temperature increase, then that means that you're looking for the one that can hold the least amount of heat, because that's the one that's going to change the most. So that's going to be the lowest one, which is gold. For number 29, this is Hess's law. So I'm not going to go over this one because there's already videos on how to do Hess's law. So you need to, this is your overall reaction that you're trying to achieve based on this information given. So if you try it out using Hess's law and you still don't get the answer, ask me again on a separate post, please. And finally, the last one for this video is 31, and it says, according to the enthalpy level diagram, what is the sign for delta H? Well, I kind of covered that already early at the very beginning of the video. You can clearly see that the products are lower in energy than the reactants, which means that it's exothermic. And you should know that the delta H for an exothermic reaction is going to be negative. So it's definitely not A or C. You're going to have either, it's going to be B or D. And again, like we said, it's exothermic. So the answer there would be a negative delta H exothermic reaction, letter B.